Hello, my name is Magnus Bach. I'm heading business development for H2MOF. So H2MOF, the starting point is that we think that the existing hydrogen storage solutions are really not very efficient in terms of energy consumption and also in terms of safety. So what we're trying to do is not, let's say, incremental improvements on the existing technologies, but rather we are trying to do something completely different. We do not increase the pressure to store hydrogen efficiently, and we do not reduce the temperature to liquefy the hydrogen to store it efficiently. What we do is to rely on nano-engineered reticulate materials called MOFs, or metal organic frameworks, to store hydrogen at low pressure and ambient energy, but at the same density levels. It could be gravimetric or volumetric density as a 700 bar pressure tank. So we deliver on the high density levels, but we can do that at low pressure and ambient temperature. And we can also do that in solid state. Think a little bit like concrete, which of course in essence will mitigate some of the safety concerns that you typically see with existing energy or hydrogen storage solutions out there. So in terms of drones, what we do think is that if you're looking at a drone application where you need long airtime or heavy payload capacity, those use cases would typically struggle a little bit if they rely on batteries. So if you use hydrogen solutions, and especially MOF-based storage solutions together with a fuel cell, then you would be able to increase the payload quite significantly and also the airtime.